morning to you all children. I welcome you all for today's learning session. Children, we started with light lesson a couple of weeks before. Now, today we are going to see part 3 of light lesson. And this lesson or this part of the lesson, part 3, is especially meant for solving problems, especially with spherical mirrors. So we are going to see how to solve problems for the spherical mirrors and based on the mirror formula and magnification. So for this, prior knowledge of the mirror formula, that is 1 by f is equal to 1 by u plus 1 by v, is required. Not only that, the Cartesian sign for all these physical quantities u, v and f is required. So based on this sign and the formula, we can solve the problems one by one. Now, before going into the problem solving, let me tell you about the reduction in portion for you people who are going to write the board examination this year. Due to the pandemic situation prevailing due to COVID-19, the CBSE board has reduced the syllabus to an extent of 30%, and even the practicals has been reduced to 30%. I have shared you the revised syllabus as well as the deleted syllabus to you last week. If you had happened to see in light lesson, the portions which are deleted is the defects of the eye. So this was one of the important topics all these years, and this year it has been deleted. So no question from the defects of the eye, especially myopia, hypermetropia and presbyopia, will be asked for this year. So that's the only portion we have covered during our online classes, which has been deleted. So other things will. Yes, children, we will start with the basics, the types of curved mirrors. There are two types of curved mirrors, as you all know. One is concave and the other one is convex. A concave will have the reflecting surface inside, whereas it has a non-reflecting surface on the outer side. And the reverse of this is the convex mirror. It will have the reflecting surface on the outside, whereas the non-reflecting surface will be inside. So when a ray of light falls on the converging mirror, which is also called as concave mirror, it is so called because parallel beams of light converges at a point called focus or principal focus, and that's why a concave mirror is also called as converging mirror. But at the same time, when parallel rays are falling on the surface of the convex mirror, they get diverged and they seem to converge on the other side of the mirror. So since they are diverging light, it is known as the diverging mirror. Now, let us revise the formulas for the mirrors, spherical mirrors. Whether it is a concave mirror or convex mirror, the mirror formula says that 1 by v plus 1 by u is equal to 1 by f. So what are these terms v, u and f? So when you look at the right side, f refers to focal length, r refers to radius of curvature, U is the object distance. Very important. U is the object distance. V is the image distance. And HO is the height of the object, and HI is the height of the image. So these are the symbols we represent for the terms which we use. Now the mirror formula says 1 by V, that is 1 by the image distance, plus 1 by U, that is 1 by object distance, is equal to 1 by F, that is focal length. So how these distance U, V and F are measured? Now when you look at the ray diagram which is above for the concave mirror, you see the distance between B and P is referred as U. So the object is kept at AB. So how far is it from the pole of the mirror? So the distance BP is the object distance which is kept by the letter U. And where is the image formed? A dash B dash is the image. So the distance from the pole till the image is the image distance. That is the distance B dash P is the image distance, and focal length is the distance between F and P. F and P is the focal length. So for concave mirror it is measured like this. You come to the right side where convex mirror is being taken. Here the object AB is placed on the left side and the image A dash B dash is obtained on the right side. So which is the object distance from the pole? So BP is again the object distance U, and the image distance is B dash P is the image distance, and the focal length is the distance between P and F is the focal length. So when you have the values of U, V and F, we can express mirror formula as 1 by V plus 1 by U is equal to 1 by F. And magnification, it is a term which refers for how large an object is being magnified or diminished. It is generally known as magnification. Magnification is given by the formula height of the image divided by height of the object. So height of the image we represent it by the letter HI, and height of the object is referred as HO. So when you do problems, especially during examination times, you get it out whether it is HO by HI or HI by HO. So be thorough. Now itself it is HI by HO. So magnification has another formula in terms of U and V. That formula is M is equal to minus V by U. So these formulas you have to bear it in mind in order to solve the problems both in concave mirror as well as in convex mirror. Children, this is a very important slide providing you the basic knowledge about the sign of all the terms H, U, V and F. So it is very simple when you understand, but it is very complex and complicated in the case when you don't understand. Now I have taken the two mirrors. The concave mirror is on the left and the convex mirror is on the right. Both of them are, the pole is being with a white dot, and the same white dot is the origin of the graph. So look at this diagram very closely. Both the mirrors are being placed and the pole of the mirror coincides with the origin of the graph. This I have already explained you during my last class. Now very simple, origin is the pole of the mirror. So any distance which you measure on the left side, it is negative, and any distance which you measure on the right side of the pole, it is positive. any distance which you measure up of the pole of the mirror, it is positive. And similarly, any distance which you measure down of the pole of the mirror is negative. So, depending upon the object position and the image position, the values of u, v, and f can be taken as positive or negative depending upon where the image is formed. So, do remember that the pole of the mirror is nothing but the origin of the graph. All distance towards the left side is negative. All the distance on the right side is positive. All the distance above it is positive, and all distance below it is negative. Children, this slide gives you whether U, V, F, HO and HI related to the convex mirror and concave mirror, whether they are positive or negative is being given. Children, again I am telling you, this table you need not mug up, you should not mug up. This has to be found from the position of the object and position of the image when you draw. So the diagrams, you have to keep it in memory. So all the diagrams of concave mirror, there are totally 6 diagrams, out of which the 5 diagrams you get real image, where the image is formed on the left side, and only in one position of the concave mirror it gives virtual and erect image, which is that when the object is kept between pole and the focus, you get an enlarged, erect and virtual image on the right side. So for the rest of the positions you will get only real image. So U, V, F, all the 3 are negative because they are formed on the left side, and only for the virtual image you get V as positive. Similarly, convex mirrors, always the image is formed on the right side, therefore V is taken as positive and U is negative. So height of the object, we always keep it above the principal axis, therefore it is plus. When the image is formed down, that image is virtual image, real image. So real images will have negative sign, and virtual images, it will be formed on the other side with upright, therefore the virtual images has positive sign. So again I tell you, don't remember or don't memorize the plus and minus. You should get it by applying the principles based on the Cartesian product as well as the ray diagram. So only when you master these two, you can able to bring in your memory without any error these values. So you should you should get well versed with the optical diagrams, ray diagrams as well as the Cartesian product. Children, let us now start solving the problems. So I have taken a very simple problem for you. Question and answers both are in this slide. Now read the question. An object is placed at a distance of 10 cm in front of a convex mirror of focal length 15 cm. Calculate the position and nature of the image formed by it. So when any problem is given, you must analyze and you have to list out the terms or the informations which are given in the problems. So what are the informations given in this problem? One is an object is placed at a distance. That means it refers to object distance. So how much is the object distance? 10 cm. So what is the letter we use to represent object distance? U. Therefore, U is equal to 10 centimeter. It is given in the problem, but when you are writing U is equal to minus 10 centimeter. Why? Always the object is kept on the left side, that is left side of the pole of the mirror. So according to Cartesian sign, so left side distance are measured as negative. Therefore, given U, that is the object distance, is equal to minus 10 centimeter, and it is a convex mirror. So you will get only two ray diagrams for convex mirrors. One is at infinity and the other one is near the pole of the mirror. Now here the focal length of the convex mirror, it is 15 centimeter. Focal length, is it plus or minus? Now focal length, what is focal length? The distance between the pole and the focus, P and F. Now for a convex mirror, a parallel ray after reflection get diverged and the rays seem to converge at F, which is on the right side. Therefore, the focal length for a convex mirror is plus 15. And what is being asked? Calculate the position and the nature of the image. So image distance is being asked. When you calculate the image distance, you will be able to predict its position. So first analyze the problem, and what are the data given in the problem, you collect it and write it with the symbols and the letters meant for it. So here in this problem, U is equal to minus 10 centimeter, F is equal to 15 centimeter, and V is what we have to find. So what is the mirror formula? First apply the mirror formula. 1 by F is equal to 1 by U plus 1 by V. And now enter all the values which are there above. So F as 15, U as minus 10, and the unknown as unknown itself, that is V. Now the next step, you have to get a formula for 1 by V. Here only children, many of you are making mistakes. So while transposing one quantity from left to the right of any equal to sign, you have to change the sign of it, opposite sign of it. So 1 by V is equal to 1 by 15 plus 1 by 10. So when you simplify this using LCM, you will get 1 by V as 1 by 6. Here is the next mistake you will do. You will get 1 by V is equal to 1 by 6, and the next step you will write V equal to 1 by 6 centimeter. 1 by 6 is wrong, but 1 by V is equal to 1 by 6, therefore V should be 6 centimeters. So we found the value of V, that is the image distance. Where is the image formed here? The image is formed on the right side, therefore it is virtual. And when it is virtual, it should be erect. Virtual and erect will go hand in hand, and it is a diminished image. It is a diminished image. So what is the ray diagram meant for it? The ray diagram for this is the rear view mirror diagram, where the object is closer to the principal focus, pole of the mirror. So this is the diagram meant for it. So I think you should do it of your own, and you should get the answer and see to it you get it correctly. Children, let us take another problem related to the same mirror, that is convex mirror. Now read the question. An object 5 centimeter in length is placed at a distance of 20 centimeter in front of a convex mirror of radius of curvature 30 centimeter. Find the position of the image, its nature and size. So after reading the question, what I told you, you have to analyze the data given in the problem. So first number that you find here is 5 centimeter. So what is that 5 centimeter? An object 5 centimeter in length. It represents the height of the object. So height of the object as HO we keep it. HO is equal to 5 centimeter. Is it plus or minus? And always the object is kept above the principal axis. Therefore it is plus 5 centimeter. And what is the next number that you get? 20 centimeter. What is this 20 centimeter? Read the question. An object 5 centimeter in length is placed at a distance of. So it refers to object distance. What is the letter for object distance? U. U is equal to 20 centimeter. That is the information given in the problem. But U is equal to minus 20 centimeter you will write. Why? The object is always kept on the left side of the pole. Whether it is a concave mirror or convex mirror, objects are kept always on the right. Therefore, blindly, the sign of U can be taken as negative. Right? So, U is equal to minus 20 centimeter. And what is the next number given to it? 30 centimeter. So, what is this 30 centimeter? Radius of curvature. Radius of curvature. It is for a convex mirror. Will the radius of curvature is on the left side or on the right side? So you all know that a convex mirror will have the reflecting surface outside and the non-reflecting surface inside. The non-reflecting surface only will have the radius of curvature. Therefore it is on the right side. Therefore R is taken as plus 30 centimeters. So from the value of R, we can find the value of F. F is equal to R by 2. That means R is equal to 2F. That is the formula. From that, F is equal to R by 2. So 30 divided by 2, that will be 15 centimeter. Again, it is plus only focal length of the convex mirror is 15 centimeter. Now, what is it you are being asked? The same V value. V is equal to how much? So apply the mirror formula. 1 by F is equal to 1 by V plus 1 by U. Now substitute the values. F as 15 and U as minus 20. Now you see 1 by 15 is equal to 1 by V plus 1 by minus 20. So you have two signs here. One with plus in the formula and with minus in the U value. So whenever you get two signs, convert it into one sign. Plus into minus, minus. Okay, then transpose the formula. So get the formula for 1 by V. So 1 by V will be 1 by 15 plus 1 by 20. So you do it on the paper only, then you will get it. So when you simplify this, you will get 1 by V is equal to 7 by 60. Therefore, V is equal to 60 divided by 7, which is equal to 8.5 centimeters. So we got the value of V as 8.5 centimeter. Hence, the image is formed at a distance of 8.5 centimeter behind the mirror. It must be virtual and erect. Now, applying the formula, magnification formula. Magnification is equal to minus V by U, and that is equal to height of the image divided by height of the object. So here letters are being taken different. So apply the formula which you know, which we have already come across. Height of the image HI divided by height of the object HO. So apply it, you will get the height of the image as 2.1 centimeter. So what is the height of the object? Height of the object is 5 centimeter. Now here you have, after the calculation, you have arrived a result. Height of the image is 2.1 centimeter. So the 5 centimeter object has converted into an image of height 2.1, which means diminished. So since it is formed on the other side, the image is virtual, erect and diminished. Okay children. Children, let us now look into a new problem. Let's go through the problem. An object 4 centimeter in size is placed at 25 centimeter in front of a concave mirror of focal length 15 centimeters. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and size of the image. So, when we analyze this problem, what are the data given in this problem we will see. An object 4 centimeter in size. So, the 4 centimeter refers to the height of the object and it is placed at 25 centimeter. So, the object is placed at 25 centimeter in front of the concave mirror. So, this 25 is the value for u. U is equal to 25 and when we take the Cartesian sign, u is equal to minus 25 centimeters. Of focal length 15 centimeters. So, the focal length of the concave mirror is equal to 15. When you include the Cartesian sign, f is equal to minus 15 centimeter. Then, what is the information given more than this? It's nothing. But what is being asked? At what distance from the mirror the screen should be placed in order to obtain a sharp image? That means screen is the object where the image is being obtained. So where should we keep the screen means at what distance the screen should be kept from the mirror. That means it is the value of v is being asked to find out. And after finding the value of v, we have to find the nature and size of the image. So the informations that are being given here are height of the image, height of the object, that is HO, it is plus 4 centimeter and u is equal to minus 25 centimeter and f is equal to minus 15 centimeter. So we have to use the formula, mirror formula, 1 by f is equal to 1 by v plus 1 by u in order to solve the problem. So let us see the continuation of this problem in the next slide. Now let us substitute the values of the given in the formula. 1 by f is equal to 1 by v plus 1 by u. So since we are asked to find the value of v, so 1 by v is equal to 1 by f minus 1 by u. So substitute f is equal to minus 15 and u is equal to minus 25. Now wherever you have two signs, I told you, you have to convert it into one sign. So minus of minus 25 will become plus 25, minus into minus plus 25. Now take the LCM and simplify. You will get 1 by v is equal to minus 2 by 75. Therefore v will be minus 75 by 2, which is equal to minus 37.5. So what does this minus sign indicate? The minus sign indicates that the image is obtained on the left side of the mirror. So when it is obtained on the left side, it must be real. When it is real, it must be inverted. And compare the size of the object and the image, you will be able to find out whether it is enlarged or diminished. So first answer is screen should be placed at a distance of 37.5 centimeter. Negative sign means that the screen should be placed in front of the mirror. So the remaining answers we will see in the next slide. As we had seen, since the image is formed on the left side, the image is real and inverted. Now let us find the size of the image. For this we will be using the magnification formula. So magnification has two formulas. One is minus V by U and the other one is height of the image divided by height of the object. So let us equate both these. Minus V by U is equal to Hi by Ho. So substitute the values. You will get the value of height of the image as minus 6 centimeter. And when you compare the height of the object with the height of the image, then you will find that it is a enlarged or magnified image. So that's it, children. These are the simple steps you have to follow one by one in order to obtain the answers. Even one small mistake for a sign will lead you confusion and your answers will be wrong. So while doing mirror problems, you must be very careful and you have to take the values exactly and apply the formula in accordance with the law. Let's look into this problem now. A concave mirror produces 3 times magnified, that is enlarged, real image of an object at 10 centimeter in front of it. Where is the image located? So what are the informations we can collect from the problem? It's a concave mirror and the magnification is 3 times. M is equal to 3. And M is equal to 3, it is M is equal to minus 3 because the magnification produced by the concave mirror is minus. And image of the, when the object is placed as 10 centimeter, U value is also given as U is equal to 10, but you have to take the value U as minus 10. Okay, now from the magnification formula we will start. Here in the slide it is given in a roundabout way, but I will give you this simplified version of this. So what is the formula for magnification? Minus V by U. M is equal to minus V by U. So substitute M is equal to minus 3. Minus 3 is equal to minus V by U. Is it? So then V by U will become 3. When you remove the minus sign in both the equal to sign, you will get V by U is equal to 3. So from this we get V is equal to 3U. Got it, children? So here in the problem, magnification, it is given as 3. It will be minus 3 because the mirror is concave mirror. And concave mirror producing real image. Therefore, the magnification is minus 3. What is the formula for magnification? Minus V by U. Okay. So if it is minus V by U is equal to minus 3. Therefore, V by U is equal to 3, which is the last step which is shown here in this slide. V by U is equal to 3. Then from this V is equal to 3 into U. Okay. Then in the problem it is given as U is equal to minus 10 centimeters. Therefore, V is equal to 3 into minus 10, that is equal to minus 30 centimeters. Here the negative sign indicates that an inverted image is formed at a distance of 30 centimeters in front of the given concave mirror. Children, now let us look into the next question. An object 2 centimeter in size is placed 30 centimeter in front of a concave mirror of focal length 15 centimeter. At what distance from the mirror should a screen be placed in order to obtain a short image? What will be the nature of the size of the image formed? Draw a ray diagram to show the formation of this image in this case. So it is one of the board questions which is asked in the Delhi region. Children, when you analyze this problem, though it seems to be lengthy, but when you look at the concepts behind it, it is very, very simple. Now, look at the numbers which are given here. 2 centimeter in size, that means height of the object is equal to 2 centimeter. So, it is plus 2 centimeter. And where is it placed? 30 centimeter. An object distance is u is equal to 30 centimeter and u is equal to minus 30 centimeter here when you take the sign. What is the focal length? Focal length is 15 centimeter. It is a concave mirror. So, f is equal to 15 centimeter. Focal length is equal to 15 centimeter. And where is the object kept? It is at 30 centimeter. Compare 15 and 30. So, 30 is nothing but twice the distance of 15. So, 15 times 2 is 30. So, when the focal length is 15 centimeter, object is kept at 30 centimeter, which is nothing but at the point C of the mirror, center of curvature of the mirror. So, when an object is kept at C, when you recall the ray diagram, it gives the same size of the image, but it gives you an inverted image. So, recall the diagram is also given here. So, when the object is kept at C, the image is obtained at C itself. So, when the object distance is equal to 30 centimeter, image distance also should be 30 centimeter. So, this concept we get it without working in the sense, without using the formula, without calculation, with the diagrammatic knowledge, we get V is equal to minus 30. So, diagrammatic knowledge will not help you and will not fetch you marks in CBSE board exam. You have to solve it. So, first write the formula for the mirror formula. 1 by f is equal to 1 by v plus 1 by u, and substitute it and you will get v equal to minus 30 centimeters. Now, draw the ray diagram. So, obviously this will be. Then magnification. Where comes magnification? Magnification, the height of the object as given as 2 centimeter, the height of the image will also be 2 centimeters. Children, now let us take up next question, which is little complicated. Now, read the question. Size of the image of an object by a mirror having a focal length of 20 centimeter is observed to be reduced to 1/3 to its size. At what distance the object has been placed from the mirror? What is the nature of the image and the mirror? So, if you look at this question and if you analyze the question, you will find lot of complications. The question doesn't provide you whether it is a concave mirror or convex mirror. And what are the informations it is being given with? It is having a focal length 20 centimeter and the size of the image is reduced to 1/3. So we can, from 1/3 we can say that the height of the image is reduced or diminished. If it is 3 times, it is enlarged. Here it is given as 1/3. Therefore, the image is diminished image. So, diminished image can be formed both for a convex mirror and for a concave mirror. So, we have to do for both the types of mirrors. Now, answer. Here it is not given whether the mirror is concave or convex. So, we will do the calculation for both type of mirrors. So, what is the magnification? Magnification is equal to 1 by 3. When we take for the concave mirror, magnification will be 1 minus 1 by 3. So, from the formula minus V by U, which is equal to minus 1 by 3, we get V is equal to U by 3. So, we got the value of V as V is equal to U by 3. So, in the mirror formula, in the place of V, you substitute U by 3. So, the mirror formula says 1 by V plus 1 by U is equal to 1 by F. So, in the place of V, 1 by V, that is 1 by U by 3, that will be 3 by U. And you substitute and find the value of F. F will be minus 80 centimeters. So, the object should be placed at a distance of 80 centimeter from the concave mirror. Similarly, you do it for convex mirror. Only thing is magnification will be here as plus 1 by 3. So, because it is a convex mirror will always give you virtual image. Therefore, the magnification is plus m is equal to plus 1 by 3. So, 1 by 3 is equal to V by minus V by U. Therefore, V is equal to minus U by 3. Previously, you got V is equal to U by 3. Here, you will get V is equal to minus U by 3. Now, substitute in the mirror formula 1 by V plus 1 by U is equal to 1 by F. You will get F as minus 40 centimeter. So, in the case of concave mirror, U is minus 80 centimeter, and in the case of convex mirror, U will be minus 40 centimeter. Okay, children. So, this you have to analyze more practically and get the solution. Children, by this we come to the end of today's session, and I have explained you both the spherical mirrors with their mirror formula as well as its magnification. Children, problems related to spherical mirrors are very important and they are very frequently asked in the examination. Since the effects of the eye is deleted, I think this year you will find a 5-mark question, especially with mirrors, in problem solving will occur. So, be careful, children, and the concept is easy and the application is little difficult. So, while you apply the formula, you must be aware of this Cartesian sign, and once when the Cartesian signs are incorrect, exact answers you will get. So, this you will achieve only by repeated practicing. So, I am going to give you more assignment on this spherical mirrors problems and try to solve them. And you have to complete these question answers in your notebook. And in the A4 sheet paper also, you can take these problems and make it as an internal assessment chapter, internal assessment topic. So, I request you to make the assignment also in this regard. Okay, children, we will meet next week, and until then we say bye from you. Bye bye.